Okay, part T, it's also about implicit differentiation. So again, it's not y equals some x. Right? This is an equation containing xy on both sides instead of y equals some x. Right? So we, again, like part D, we differentiate both sides. Okay, so this part, the derivative is d over dx. Right? It's d over dx x, right, times tangent y plus x times d over dx tangent y. Right, plus this part equals this part is d over dx y, right, minus, okay, d over dx 0, 1, right, d over dx 1. So this part, d over dx x, it's just 1 times tangent y plus x times. So here we use a chain rule. First, tangent something, the derivative is second square, right? It's derivative second square. And y is a function of x, right? Remember, in part D, we have discussed y is a function of x. So you have to use times dy over dx. Okay, so here's the difference. D over dy, like sine y, right? Say d over dy sine y is just cosine y, right? But d over dx sine y, if y is a function of x, it's cosine y times dy over dx. Okay, so this is the difference. Equals the right side, it's dy over dx, right? Minus, here it's 0, right? So it's just like this. Then same thing, right? We move every terms containing dy over dx to the left, right? To the left. We move this to the right. So it's x second square y minus 1. Right. We can also write it as y prime, right? Times y prime equals the right side tangent y. Okay, so y prime is tangent y over. Wait, is there a mistake? Yeah. Right. When we move this to the right, we have to put a negative sign, right? So it's negative tangent y over 1 minus, over x squared, x second y squared minus 1. Okay. So this is the answer. Part F. Right, part F, we come back to the chain rule, right? Just a normal chain rule. Right, first ask yourself, right, what's the derivative from outside to inside? The first function you encounter is lowering something, right? What is lowering something's derivative? It is 1 over this thing, right? So it's 1 over second x. Then you just ignore lowering, right? What is second x's derivative? It is tangent x, right? It is tangent x second x, right? So the result is tangent x. Okay, so here it is f. G lowering, right, second x plus tangent x. So again, from outside to inside, the first is lowering something, right? The derivative is just like here. The derivative is 1 over this thing, right? Okay, then times, after ignore lowering, it's just second x plus tangent x derivative, right? secant x derivative is secant x times tangent x. Right? Tangent x's derivative is secant x squared. Right? So right, and you can simplify. Right? Here it's the numerator, this part, you can extract the common factor secant x. So it's secant x tangent x plus secant x. Right. Here it's over this part, secant x plus tangent x. Right. So these two cancel out. It's secant x. Okay. Last part, h. Y is sine inverse 1 minus x. Right. So again, first, from outside to inside, it's sine inverse something's derivative. Right. Sine inverse something's derivative, it's what? Right. Is 1 over 1 minus this thing, square root of 1 minus this thing square. Right. So the first part is 1 over square root of 1 minus this thing square. Right. Times, so now ignore sine inverse 1 minus x, the derivative is negative 1. Right. The derivative is negative 1. So this is a result. Okay. Alright, so that's all for this part. So this part is just chain rule and the implicit differentiation.